My alpha is 0.
Which one? Number 3?
Number 3, yeah.
The answer is not right.
Okay.
Okay, I give you a hint. This coaxial transmission line have a certain L per meter, a certain C per meter. So if you take square root L over C, it will give a value. And that value is constant anywhere along the conductor. For the whole conductor, it's only 1 Z. If you buy a transmission line, coaxial transmission line, you have like 50 ohm, 75 ohm, whatever ohm. It's the same. So that's the clue. And a shorted conductor, you can look at number 2D there. It's like a transmission line terminated with a 0 ohm. So a short circuit is like 0 ohm. And number 4, a broken conductor is like open circuit. It's like number 2E, which is a large, very large resistor. That's the hint.
So the alpha is maybe 0.33.
No, if you do number 3D and 3E, if you do number 2D and 2E, you can do number 3 and 4. It's the same.
Oh, wait, the alpha is 1. Is it? Is it correct?
Okay, let's do number 2. Z1 is still 600 ohm. Z2 is actually 0 ohm, right? 2D. So alpha equal to?
0 minus 600.
Yeah, give me the full answer. Come on. What's the formula? Alpha.
2 minus Z1 and over.
What's the answer?
+1.
So what's the answer?
-1.
-1.
-1.
And beta? 0.
Yeah.
Number 2E, Z2 now is infinity. Alpha is?
Z1.
1.
Because infinity over infinity
And beta
is 2.
2. Therefore, you can answer number 3 and number 4. Anyone here has a problem to answer number 3 and number 4 based on number 2D and E? What's the answer for number 3? Number 3, the answer is the same as 2D. Number 4, the answer is the same as 2E. How? Huh?
I know. No. But how to get impedance for number 3?
Come on, David. The formula is shown up here. Right? The formula is shown up there. You can leave Z1 as it is. Because Z1 is here. You can leave as it is. Z2, you know already, as given by short circuit or open circuit. Correct?
Okay. So we don't bother. Okay, we don't bother about the impedance, right?
Yeah, because in the end you get the answer still. Okay, so the answer is this one, same as 2D, and this one same as 2E. Okay, if you do the calculation, you get the answer. Okay, let's move on. Computation of tower voltage. So this is interesting part. Just now, just introduction or revision. If you have a surge coming from the middle of the line being struck by lightning, so the surge will start propagate from that point. Because the line is bare, when it's being struck by lightning, it will propagate in both ways, to the left as well as to the right. Correct? Therefore, you will have attenuation along the line, of course. But first of all, the current will split into 2. The current will split into 2. And therefore, the surge that propagates to the right as well as to the left is given by this formula. Okay? Which is half Z multiplied by I. Of course, when it reaches the tower, it will see a discontinuity. And at the tower, with the cross arm and so on, because this is a earth conductor, or is it phase conductor? Okay, phase conductor, doesn't matter. You will have, if it's phase conductor, then you don't have discontinuity. You just see a line going through. But I'm talking about at the point of strike. At the point of strike, you will have a voltage generated. Okay? And this voltage, you can actually compute. So the voltage is actually, Z over 2 multiplied by I. Why over 2? Because you can see there, it's like you have a current source, you have two surge impedance. So this is the equivalent circuit. One to the left, one to the right. So the current split into 2. Therefore, V here is equal to this formula. This is from your circuit theory. Okay? Any question? I can ask you a question. Does the voltage change with X? X being the distance from the point of strike to the tower. Does the voltage change with X? Any answer? This voltage change with X, or does it not? V ni berubah dengan X ke tidak? Ada jawapan tak? Jawapan dia?
From my opinion, V does
not depend. Meaning to say, you are right. If it strike here, the same voltage. If it strike here, same voltage. As long as it strike the wire. Okay? Anyway, so the voltage at that point will be the same. Okay, move on. I've already given to you the equation, but the voltage equation is equal to Z2 multiplied by I. But if the current has a certain wave shape, the voltage will follow the same wave shape because Z is in ohm. For example, if the current is having this shape, then the voltage also will have the same shape. You just multiply by Z over 2. Okay, so that's what it means. The surge propagation will follow the same shape. So this is the first point there. You can have the shape in terms of mathematical equation like this, okay? And then the voltage will follow the same shape. Now, the equivalent circuit is given by a current source with the ZE now, the earth or the wire. Okay, E here is actually, it should be Z only, but I put earth there, doesn't matter. So you can ignore E. So Z, 2Z, and therefore the equivalent circuit is like this. I, the voltage there, and equivalent. And Z equivalent is equal to Z in parallel with Z, the 2Z. Okay, if we ignore the E. So that's why we have Z over 2. Okay? For example, if this is a direct strike to the phase conductor, okay? If your phase conductor have 300 ohm, so typically 300 ohm, this is normal. It's not resistant, by the way. It is surge impedance. So it's not, I'm not saying it has a certain resistance of 300 ohm. I'm saying it has a surge impedance of 300 ohm. So this 100 ohm, and let's say you have 20 kilo amp lightning strike. If you multiply this strike current with 300 ohm divided by 2, you get 3 megavolt. So there's a large voltage propagating both ways, left and right. Okay? Now, you can model the lightning strike by just I, or to be more accurate, I in parallel with its, because it's an ideal current source, with its surge impedance, ZS. So this is also normal. We have what we call equivalent circuit for lightning for a current source, just a current or current in parallel with the ZS. The one that we have before, ZS is equal to infinity. But this is ideal. That is ideal. The non-ideal one, ZS is not infinite. It has a certain, maybe few thousand ohm impedance as shown there. So the equivalent circuit of lightning current source can be more accurately modeled by I in parallel with ZS. And if that is the case, then your Z equivalent now become the parallel of ZS with Z with Z. Okay, so you have no. Okay, let's move on. Let's say now it strikes the earth conductor, but the earth conductor is actually at the top of the tower. You understand? You see, at the top of the tower, you have earth conductor. And the earth conductor having Z, let's say Z earth, strike here. So the current now split into 3. I1, I1, and I2. Because this is also, the tower also have a certain Z tower. So the current now split into 3. Okay? So there are 3 current paths, as you can see there. Therefore, the equivalent circuit will become Z source parallel with Z tower, parallel with ZE, parallel with ZE. 4 Zs in parallel. Okay? If you understand what I have discussed just now, can you solve this problem? Determine the prospective crest voltage. I mean, what is the voltage value if ZE or the transmission line or the earth line impedance is 600 ohm and Z tower is 150 ohm. In the first case, the lightning is 20 kilo-amp peak. It strikes the top of the tower with single earth wire connected at the top. So what it means here is you have tower, you have a single earth wire. Because sometimes tower can be like this. You have a tower, you can have 2 earth wire, cross arm like this, 2 earth wire on the left as well as on the right. So you have, you can have 2 earth wire or single earth wire. In this case, only single earth wire. Single earth wire. Okay, single earth wire. So what is the answer for the first one? If the current striking the top of the tower like this. So what is the voltage at that point? Peak voltage. So you need to do equivalent circuit. So for number 1, the equivalent circuit will be 20 kilo-amp source current, but you don't have any ZS given. So ZS you have to assume infinity. Okay, you can put ZS, but it's equal to infinity because you are not given. So you can assume that infinity, but you have 2 earth wire, 1 to the left, 1 to the right, but you also have the tower surge impedance, ZT. Okay, so you need to calculate the voltage at that point. Any answer? So very simple. Convert this into equivalent circuit. 20 kilo-amp, Z equivalent, and this is your voltage. So VT is equal to Z equivalent times 20 kilo-amp. And Z equivalent is equal to the parallel of ZE, ZE, and Z tower. And Z tower is 150 ohm, ZE is 600 ohm. Okay, any question? You can continue on with number 2. Now, in number 2, ZS is specified. So you can add this ZS instead of infinity, 2500. Number 3 is no earth wire. This is like communication tower, no earth wire. It's striking the tower, but no earth wire. So it's like the voltage or the currents goes straight into the tower to the ground. So you just need to calculate the voltage at the top of the tower. It's like communication tower.